Welcome to this explainer on Cambridge AS and A-level mathematics. Go ahead and take a deep, settling breath. Close out your other tabs, silence your notifications, and let your mind dial into this space. Today, we are stepping into a minimalist, deep focus study session. We are cutting through the noise, the stress, and the textbook clutter to focus our attention completely on the critical architecture of topic 3.2, logarithmic and exponential functions. In this masterclass, we are going to calmly peel back the complex layers of the Cambridge syllabus. We will reveal the pristine, underlying logic that the examiners are actually looking for. Whether you are aiming to simply understand the fundamental, beautiful mechanisms of exponential growth, or you are actively targeting that top-tier A-star grade, this session is engineered to align your cognitive pathways perfectly with the exact expectations of the Cambridge assessment framework. Imagine a clean, dark mode digital tablet in front of you. Your focus level indicators at 100%. So let's get right into it and start building your mastery. Okay, let's dive into this. Here is our completely stress-free study session blueprint. We will start with the 15% reality, move smoothly into mastering the core principles, and map out the standardized procedural framework. Then we'll tackle essential data interpretation skills. Finally, we will protect your hard work by covering the method mark strategy and the top 3 examiner warnings. Let's get started. Section 1, the 15% reality, high-yield examination stakes. In the vast, sometimes intimidating landscape of the Cambridge Mathematics 9709 syllabus, it is incredibly easy to become overwhelmed by the sheer volume of content you are expected to hold in your mind. However, I want you to look at this space analytically. Elite exam preparation is not about reading every page of the textbook until your eyes ache. It is about deeply intentional focus. It's about channeling your energy where it generates the highest possible return on your time. Mastering this single interconnected topic provides a massive high-yield return. As you can see right here on the chart, approximately 15% of your total examination marks are dedicated entirely to topic 3.2, logarithmic and exponential functions. I want that to sink in for a moment. Mastering logarithms and exponentials acts as a heavy, solid anchor for your overall grade. When you sit in that quiet exam hall and you turn the page to see the characteristic e to the power of x, or the natural logarithm, ln, you absolutely should not feel a spike in your heart rate. You shouldn't feel panic. Instead, you should feel a quiet, powerful sense of confidence, knowing that a full 15% of the paper is well within your controlled practice grasp. You are simply executing a routine you already know perfectly. Section 2. Mastering the core principles. What Cambridge expects. Before we even touch a pen to manipulate complex equations, we must pause and understand exactly what Cambridge expects from a top-tier candidate. The syllabus outlines highly specific assessment objectives. These are the distinct cognitive domains the examiners are actively hunting for on your paper: knowledge and understanding, application, and critical analysis. To make this concrete, let's observe 2 scholars in our virtual study space. We'll call them Alex and Sam. Alex is highly precise, an absolute master of raw knowledge, but Alex tends to crowd the page with dense, unstructured algebraic facts, hoping the examiner will find the right answer in the mess. Sam, on the other hand, is creative and dynamic, excellent at application, but occasionally drops crucial high-level analysis marks by losing focus on the specific command words in the prompt. Suppose they are looking at a high-tariff past paper question that says, analyze the exponential decay of a radioactive substance over time. Alex sees this, immediately writes out the formula, n of t equals n sub 0 times e to the power of negative kt, and starts crunching numbers, demonstrating perfect foundational knowledge. But Sam calmly taps the screen and points directly to that crucial command word, analyze. Sam reminds Alex that analyze means they cannot just state the formula and solve for a variable. To secure full marks, they must systematically break down the mathematical relationship, providing a step-by-step evidence-based reasoning for exactly how the rate of decay changes as the time variable progresses. By slowing down and isolating these exact assessment objectives, you ensure that every single line of working on your page is a direct, deliberate response to the examiner's core demands. Nothing is wasted. Section 3. The standardized procedural framework. A sequence for success. And this brilliantly illustrates the 5-step procedural framework that guarantees systematic, completely serene processing. Let's watch Alex and Sam use a shared digital workspace to tackle a notoriously complex challenge: the hidden quadratic equation involving exponentials. The equation on the screen is e to the power of 2x minus 5 times e to the power of x plus 6 equals 0. Step 1 is to calmly identify the key elements. Alex scans the structural architecture of the equation and identifies it not as a terrifying exponential nightmare, but simply as a standard quadratic equation in disguise. Step 2 is to apply relevant principles. Sam steps in here, suggesting a clean algebraic substitution to keep their page layout perfectly pristine. Sam writes, let u equal e to the power of x. Instantly, the intimidating equation transforms into a comforting, familiar structure, u squared minus 5u plus 6 equals 0. Step 3 is to execute the analysis with perfectly clear working. Working together, they factorize the simple quadratic effortlessly, finding that u equals 2 and u equals 3. But here's where focus often slips, which brings us to step 4, verify the results. Alex calmly reminds Sam that they aren't solving for u, they are solving for x. They must substitute back. So they write out e to the power of x equals 2 and e to the power of x equals 3. To isolate x, they take the natural logarithm of both sides, beautifully demonstrating the inverse relationship between exponentials and logarithms. They land on x equals ln 2 and x equals ln 3. Finally, step 5, present in the appropriate format. Sam checks the original exam prompt, meticulously noting it requires the final answer to exactly 3 significant figures. They punch the natural logs into their calculators and execute the final rounded presentation. This sequence, this standardized, predictable rhythm, completely removes the panic of the unknown. You are just running a deeply ingrained program.
Section 4. Essential Data Interpretation Skills. Decoding Complexity.
Before we deploy these core interpretation skills, let's take an intentional focus reboot. Let's breathe and refocus your mind. Before we analyze this next visual framework, make sure your daily study dashboard is complete. Subscribe to Ace the Exams, that's at Ace the Exams, right now, and enable all notification alerts. Whether your specific target is an IGCSE, an O-level, or a Cambridge AS and A-level A-star, this channel is your dedicated, weekly space for stress-free, highly analytical exam mastery. Consider that your mid-session mental reset. Now, let's step into the practice arena for Challenge 1, the mindful scan. Under strict exam conditions, you are going to encounter dense complexity. You must extract accurate data from tangled texts, interpret mathematical relationships logically, and draw firm, evidence-based conclusions. Imagine a highly complex Cambridge source chart appears on your screen. It's displaying an exponential growth curve for a biological population, and it is entirely surrounded by a dense, intimidating paragraph of explanatory text. You have a 60-second visual countdown timer ticking down in your mind. Your task is to extract the single most high-yielding core trend without letting your heart rate spike. How do you do it? You simply look past the complex biological terminology. You calmly scan the mathematical architecture of the axes. You notice a beautiful detail. The y-axis is logarithmic, it reads ln y, while the x-axis is linear, tracking time. And the resulting graph drawn between them is a perfectly straight line. Your mindful scan immediately decodes this secret. A straight line on a semi-logarithmic plot mathematically guarantees an underlying exponential relationship in the raw data. You didn't need to read the paragraph. You effortlessly extracted the core truth by maintaining total structural discipline. Now, what's really interesting about this slide is how we can clearly contrast a standard candidate's mindset with a top-scoring evaluative candidate's mindset. Welcome to Challenge 2, the imperfect answer. Let's look at how our scholars navigate a structural roadblock when evaluating the long-term validity of a mathematical model. The standard candidate executes the algebraic steps systematically, finds a neat numerical answer for a future population size, and simply stops writing. When the follow-up question asks if this pure exponential population model remains valid as time approaches infinity, the standard candidate writes yes because the calculation shows continuous growth. They accept the theoretical assumption without question. The top-scoring evaluative candidate, however, pauses. They employ a framework we can adapt for math, similar to the Peel structure used in essays: principle, equation, execution, logical link. They question the baseline assumptions. They write a pristine, logically verified sentence pointing out that in the physical reality of the context, environmental carrying capacity like limited food or space will eventually restrict growth. Therefore, they argue, the pure mathematical exponential model breaks down over extended periods, and a logistic model would be more appropriate. A top candidate doesn't just do the math. They state the principle, they show the equation as hard evidence, they execute the calculation flawlessly, and then, crucially, they logically link their numerical result back to the physical reality of the prompt. This is exactly how you elevate your response from merely doing calculations to demonstrating elite A-star evaluative thinking.
Section 5. The Method Mark Strategy. Process over perfection. I want you to lean in and listen to this direct alert from a Cambridge senior examiner very carefully. It is literally printed on the slide. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Let that sink in and let it alleviate your anxiety. The Cambridge examiners are not your enemies. They are not sitting in a room looking for tiny reasons to penalize you. They are actively searching your paper for opportunities to award you marks for your correct analytical process. This is what we call the marks per minute flow formula. If you follow the serene, systematic steps we observed with Alex and Sam, and you cleanly document your logic line by line down the page, you are building an incredibly strong safety net. Suppose you are under pressure and you make a minor, frustrating arithmetic error right at the very final step of a massive logarithmic equation. If your paper is a chaotic, unstructured scatter of numbers flowing randomly around the margins, the examiner cannot trace your thought process, and you lose everything. But if your working is a pristine, visually satisfying progression down the page, clearly showing the accurate application of the power rule, the product rule, and the quotient rule of logarithms, the examiner will seamlessly award you almost all of the method marks. Your structural discipline literally protects your grade from your own human errors. In the Cambridge ecosystem, a logical process is truly more valuable than isolated perfection.
Section 6. Top 3 Examiner Warnings. Avoiding Common Pitfalls. So the crucial point of our session today is knowing exactly what these documented historical student mistakes are, so you can calmly and actively avoid them. These are the traps hidden in the paper. First trap, confusing cause and effect within the data. When dealing with exponential functions representing real-world scenarios like investment growth or cooling temperatures, students often misinterpret which variable is actually driving the other. Always trace your mathematical logic back to your independent variable. Time, for instance, ticks forward regardless of the temperature. Time is independent. Second trap, forgetting to check the required format and presentation. You can execute a completely flawless mathematical symphony on your page, but if the examiner explicitly asks for an exact logarithmic form, like leaving your answer as ln5, and you punch it into your calculator and provide a rounded decimal, like 1.61, you instantly drop easy, completely avoidable presentation marks. Always do a final polish review pass to verify the required format. Third trap, providing answers that are not specific to the context given. Let's say you solve a complex hidden quadratic, like the one Alex and Sam tackled, and your mathematical answer yields a time value of -3. Algebraically, -3 might be a perfectly correct root of that isolated equation. But if the context of the question is the time elapsed since a chemical reaction began, you must use your evaluative skills. You must explicitly state on the paper that a negative time value is physically impossible in this scenario, and you must cleanly reject that root. By hardwiring these 3 specific warnings into your personal procedural framework, your responses will become perfectly frictionlessly aligned with the examiner's precise criteria. As Alex and Sam look at their completed, absolutely flawless response paragraph on their digital notebook, their focus meters are maxed out, and hopefully yours is too. We have distilled this entire masterclass into 3 core focus pillars you can take into the exam room. The 3-step question scan for decoding, the marks per minute flow formula for perfect pacing, and the final polished review pass to protect against presentation traps. So I want to leave you with this final vital question to meditate on. Have you structured your conceptual understanding so deeply that a completely unfamiliar mathematical context won't break your procedural framework? The goal of your daily revision isn't to try and memorize every possible combination of numbers Cambridge could throw at you. It's to build a calm, impenetrable, systematic recipe for problem solving. Maintain your elegant structural discipline, trust in your carefully laid procedural framework, and I promise you, the marks will naturally, inevitably follow. Before you close this session and move on with your day, make sure to subscribe to Ace the Exams at Ace the Exams. Click the notification bell to lock in your future focus deployments. And right now, leave a comment below identifying the specific subject, the tier, and the exact target grade you are currently meditating on. Stay calm, stay focused, and I will see you in the next strategy session.